As the Earth rotates over 24 hours, the planet responds to the extraordinary power of the sun. Each day, 170 million gigawatts, over 7,000 times the power that humanity consumes, rains down on the surface, triggering a wave of activity that never ceases. At dawn, plants and plankton begin to photosynthesize, using the light to make sugars and starches, the basis of the food chain. The power source for almost all living things. Sunlight drives wind and weather around the globe. When the air cools at night, it triggers much of the Earth's rainfall. We are part of this circadian pattern too, built to respond to the daily influx of energy from above. The cells in our bodies need sunlight to create vitamins in our skin. Even the flight paths of planes reveal our intimate relationship with the sun. Aircraft travel westwards in the morning to extend the day, and eastwards in the evening to reduce the night. But ironically, the biggest threat to this finely balanced arrangement is from the same thing that allows it to exist in the first place. The energy given off by the sun. The SDO satellite records the ultraviolet radiation released by our star. Charged particles, fractions of atoms, protons, electrons, and neutrons are constantly thrown out, along with massive pulses of electromagnetic radiation. But occasionally, the sun throws out what's known as a coronal mass ejection. This supercomputer visualization shows a cloud of plasma millions of kilometers wide, racing towards the Earth. If these solar particles were free to hit the Earth's surface, they would do serious damage to any living thing, producing fatal mutations in their DNA. Fortunately, the Earth has a defense. An invisible force field called the magnetosphere surrounds our planet, visualized here in unprecedented detail. These images are generated by data from 5 magnetically tuned satellites. Called Themis, the network of spacecraft reveals the force field as it is constantly bombarded by the sun. The shape of the field is produced by the sheer force of the radiation hitting it. A nebulous teardrop 200,000 miles in diameter. As wave upon wave of solar particles strike the magnetosphere, most are deflected. But when a coronal mass ejection arrives, the charged particles peel open the magnetic field's outer layer. Particles are now free to rush in towards the planet. The Earth's inner magnetic field steers the radiation towards the poles, triggering one of nature's most remarkable sights. The northern and the southern lights. And here, we can see the Earth's second layer of defense. Giant ribbons of plasma stream downwards, encircling both the north and south poles. As they strike the upper atmosphere at extreme speed, they excite the molecules of air. The process makes the air molecules glow. The oxygen radiates red and green, the nitrogen blue. Energy that would otherwise mutate all life on Earth is dissipated by the upper atmosphere. In this way, the Earth has shielded itself from the sun's deadly radiation for millions of years. But even this extraordinary apparatus is only one part of how the atmosphere protects life. Down below, there are yet more powerful systems, without which there may be no life at all.